Hello, my dear students. Today's lesson is differentiation. It's a new topic in IGCSE syllabus since 2020. Before, we used to teach it to AS and A-level. Until now, we are teaching it to AS and A-level also. But today's lesson, I'll make it as simple as possible for the IGCSE students. First of all, you know about the gradient of the line. It's easy. The gradient of the line, it is rise over run, which is difference in y's over difference in x's. Here is the gradient of the line, and I'll give you some examples. In this case, the car is, you're coming from left to right, and you are going up the hill. So it is positive gradient. Going up, positive gradient. Going up, positive gradient. Then, in this case, when you're coming from left to right, and you are sliding down the hill, whee! When sliding down, it's negative gradient. Sliding down, it's negative gradient. In this case, your car is moving horizontally where no ramps, no going up the hill, no sliding down. It is horizontal line. So horizontal line, it has neither positive nor negative gradient. Going up, positive gradient. Going down, negative gradient. Horizontal gradient is a 0. What about gradient of the curve? Gradient of the curve is the gradient of the tangent to the curve. Say it. Gradient of the curve is the gradient of the tangent to the curve. In this case, this is the approach of differentiation, which usually we have to start this explanation before any differentiation lesson, whether for IG or AS. This is the blue curve, and here is the line segment AB. We can find the gradient of the line segment AB. This is point x1, and this is x2. This is the x coordinates of points A and B. And here is the y coordinate of point A, and here is the y coordinate of B. So in order to find this vertical height, it is y2 minus y1. In order to find this horizontal distance, it is x2 minus x1. So the gradient is y2 minus y1 upon x2 minus x1. We usually say it is rise over run. What's the gradient? The gradient of any line. Choosing any 2 points on the line, it's y2 minus y1 upon x2 minus x1. Repeat, y2 minus y1 upon x2 minus x1. This point B started to approach point A. When it came here, the vertical distance is decreasing and the horizontal distance too. Then point B started to approach point A more and more. And this big red triangle, it became the green dotted triangle, and then it became this black tiny triangle. It is so tiny, such that the distance on the horizontal, we don't call it x2 minus x1. We call it dx. And the vertical distance, which is the difference in y's, y2 minus y1, it's so tiny, so we call it dy. And now the gradient of the tangent to the curve as this line segment AB, when point B approaches point A, here's point B approaches point A, and this red line is becoming like that, and then becoming like that, until the line segment turns into a tangent. Tangent means touches. Tangent means touches. So this line, it's now a tangent to the curve, and the distance between x's and between y's, the big distance y2 minus y1 and the big distance x2 minus x1 is now so tiny, and we call it dy by dx. So now the gradient of the tangent to the curve is now dy by dx. And this is the new thing in differentiation that differs from the chapter of coordinate geometry, which we call it straight line graphs. Now we are dealing with tangent to the curves. Let's go. How to find the differentiation of some terms? First of all, you have to know that there is a rule. The rule states that power goes down, decreases by 1. Say it. Power goes down, decreases by 1. For example, if we have here a power of 10, power goes down, decreases by 1. It means the 10 goes down. It will be 10x to the power of, yes, power of 9. Power goes down, decreases by 1. What about x power 2? Power goes down, decreases by 1. So it is 2x to the power of 1. We can just write it 2x. What about this x? X power 1. Power goes down, it will be 1x to the power of 1 minus 1 is 0. And monkey power 0 equals 1. Monkey power 0 equals 1. What about this monkey? It's in the video concerning indices. So it is just 1. What about a normal number like a 5? A constant, you mean? Yes, constant number. Its derivative will be a 0. Any constant, its derivative is 0. First of all, we have to know about the titles. What's written on this side? This is y as a function of x, which is the equation of the curve. If you say that y equals 5, it's a horizontal line, y equals 5. If you say y equals x, it's a line that is inclined at 45 degrees. Y equals x, a line that is inclined at 45 degrees, positive gradient. What about x squared? No, x squared is a parabola. It's a quadratic function. What about x power 10? What about all these functions? All these are equations of curves. So now on this right-hand side of the table, for each function, we'll find for y, we find y dash, or we call it dy by dx. We can also, if the function is f, we can call it f dash of x, which is the first derivative, which is also the gradient of the tangent to the curve. Repeat, it's the gradient of the tangent to the curve. Let's go back. What about tan theta? This angle theta, the definition of this angle theta, it is the angle that the line makes with positive direction of x-axis. So in this case, theta is an obtuse angle. Here, tan theta sure will be positive. We took before in trigonometry. 10 acute angles are positive. 10 obtuse angles are negative. So here tan theta is negative. This means that the gradient of the tangent to the curve is negative. In this case, theta is 0. So because theta is 0, tan theta is 0. Because I wrote here in the table, we can name it the first derivative, we can name it differentiation, we can name it the first differential, we can name it tan theta, which is gradient of the tangent to the curve. Let's go to the rule of power goes down, decreases by 1. Power goes down, decreases by 1. What about this power of 7? When it goes down, it will hit the 4. It will multiply it. So 7 multiplied by 4 is 7 multiplied by 4, it is 28. So 7 multiplied by 4 and power goes down, decreases by 1. So we'll multiply them, of course. 7 times 4, it's 28 and x to the power of 6. It's easy. Differentiation is so easy. And now, what about square root? What about square root? What about cubic root? What about denominators? How can we deal with it? We don't deal with denominators, we don't deal with roots. Repeat, we don't deal with denominators, we don't deal with roots. We don't deal with denominators, we don't deal with roots. How shall we do it? I'll tell you. We have to be very strong in the chapter of indices because everything here is depending on your knowledge of indices. You know that fractional power means a root. Fractional power means a root. Fractional power means a root. Cubic root, it is x to the power of third. Square root, it is x to the power of half. What about this one? It has cubing on the x. At the same time, it is the fifth root. So it is x to the power of 3 over 5. We don't deal with denominators. You know quite well, when x is sitting below the table, Let her come above the table, but she has to change the power. She has to change the sign of the power. It will be x to the power of -2. Negative power means she doesn't like her place. She changed the place from below the table. She goes above the table. What about this 8? This 8 is above the table. Nothing will change. What about the square root? When it goes up, it will be 8 as it is. And the square root of x, you know it is x to the power of half. Is it really x to the power of half? That's it? No, it was below and it came above. So x to the power of -half. Okay? Now let's start differentiation. Power goes down, decreases by 1. This power will go down, power half will go down. It will be half x to the power of, how it will decrease by half? Or decrease by 1. Half minus 1 is -half. It's easy. You can use it. You can use the calculator to find it. Okay? But I want to teach you how to find it without calculator. It's easy also. How to subtract half minus 1. It is half minus 2 over 2. So it will be -1 upon 2. Okay? What about power third? Power goes down, decreases by 1. So it will be a third, and here is x. You can find it on the calculator. It is third minus 1, decreases by 1. So it will be third x to the power of -2 thirds. How to find it without a calculator? You write here third minus 1 is third minus 3 over 3. Something over 3 minus something over 3 equals something over 3. So it will be -2 thirds. It's easy to find any calculation without using the calculator. Now, what about this one? Power goes down, decreases by 1. So it will be 3 over 5, x to the power of 3 over 5 minus 1. It's -2 over 5. Power goes down, decreases by 1. First of all, whenever you see a root, a square root, a cubic root, or whatever, or you find x in denominator, you have to put it in index form. X to the power of something. Then you start singing power goes down, decreases by 1. Okay? Now, this power -2, when it goes down and it decreases by 1, think about it. -2, when you minus 1, it will be what? -3. Okay? What about this one? Power goes down. Oh, it will hit the 8. No problem. It's -half and multiply by 8. And then x to the power of -half minus 1 is -1.5, which is -3 over 2. All these are terms. What about an algebraic expression? You will deal with every term individually. Everyone is having a case. Power goes down, decreases by 1. 5. This one, of course, will be -4, x to the power of -3 over 2. You should finish it up. And this one, power goes down, decreases by 1. It will be 10 x to the power of 4. But what about this one? And what about this one? They are not ready to differentiate. We have to maintain it as put it in index form. So I have to repeat the whole, expression, algebraic expression, starting from 2x to the power of 5, and then we don't deal with denominators. Okay, x power 5 will go up, so it will be plus 3x to the power of -5. What about the 7 square root of x? Fractional power means root. So it is 7x to the power fraction, which is half. What about the 10? You know what about the 10? It will vanish because it's constant. Now let's start the first one. 5 will hit the 2. It will be 10x to the power of 4. Done. What about the next one? 3 over x to the power of 5. 3x power -5. This one, power goes down. It will be -15 x to the power of negative 6, because negative 5 minus 1, it's negative 6. And the half will hit the 7, so it will be plus 7 over 2. X to the power of half minus 1 is negative half. And then what about the 10? It is 0. Shall we write the 0? No need. No need to write it. Next, stationary points. This is a major part in differentiation, because usually they ask us to find where are the stationary points on a given curve. The coordinate, x coordinate of the stationary point, for example, or x and y coordinates. Stationary point means where the car stops temporarily. Here you're driving your car above the hill. Vroom, vroom, vroom. Then take a rest. Then, whee, you slide down. When you are going up, then positive gradient. Sliding down, then negative gradient. What about this point? This point is critical. In some books, we name it the critical point, because it is exactly in the middle between the status of going up and sliding down. When you take a tangent, because you know that we deal with gradient of the tangent to the curve. When you take a tangent here, you will find it positive gradient or negative gradient or zero gradient. Zero, because it's horizontal, exactly at the top of the hill. In this case, you are sliding down, then going up. Here's your car, huh? Ferrari. Sliding down like, whee! Then you take a rest at the bottom of the valley, and then vroom, 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 vroom. Then going up. In this case, you're sliding down, then negative gradient, going up, then positive gradient. What is between sliding down and going up? You have to take a rest. Okay, I'll take a rest. Where? In the bottom of the valley, exactly. At the critical point, yes. In some books, we call it critical point or turning point. We call it stationary point. Most probably, it is stationary point in most of the books. When you take a tangent here, this tangent is going up or sliding down or horizontal, horizontal. So gradient of the tangent to the curve is 0. Gradient of the tangent to the curve is 0. Gradient of the tangent to the curve is 0. Where is that? At stationary points. Stationary point could be the maximum point, which is the top of the hill, or it could be the minimum point, which is the bottom of the valley. In these two cases, the gradient of the tangent to the curve is 0. There is a test. Here I wrote it in bold black. A test, we call it the second derivative test. It means you make differentiation for the first differentiable we did before. So you have, for the first differential you made before, so we call it the second differential, or we call it the second derivative. It will show you very clearly the nature of the point. If you see the word nature of the point in any exam, he means he wants you to tell him whether it is a maximum point or a minimum point. This is the nature of the point. How to find it? We make the second derivative test. The second derivative